Hey everybody, we're back. Let's go into section 14, which is function model construction. So let's talk about something that we all like to talk about, which is money. Let's talk about Jeff Bezos' net worth over this amount of time. So as I'm graphing this on the x-axis, we're going to graph this as years after 1994. So let's convert this to number of years after 94. So this is 0 years after 94. This is 1998. It's going to be 4 years later. And then we'll have 8, 14, 21, 24, and 26 years after, which is that 2020 mark. And then on the y-axis here, we'll put this in as money or net worth. And of course, since we're talking about Jeff Bezos, we're talking about billions of dollars. All right, let's go ahead and graph this data. So here at 0 years after, where he is worth $0. At 4 years after 1994, he's worth 12 billion. That's not bad for working for 4 years. At 2002, or 8 years after, it's 10. So let's look at 8. We're going to go up to 10. So we kind of dips a little bit there. At 14 years after, he's worth 2 billion. So he lost some of his wealth. At 21 years after, he's worth 50. So he's climbing pretty significantly. At 24 years after, he's worth 100 billion. And at 2020, that's 26 years after, he's worth $136 billion. Let's go ahead and connect that graph if we can. And if we look at this, we see that this isn't linear, it's not quadratic. This looks like a cubic approximation. So let's go ahead and use our calculator to not just say, hey, it's cubic. Let's actually write a regression for the best fit curve, which in this case is going to be a cubic model. Okay, so what we're going to do is we're going to tell your calculator exactly what these values are. So here, when we're talking about this list, we're going to call this list 1 in our calculator, and this will be our list 2. So let's go ahead and pull up our calculator. So go ahead and take out your graphing calculator here. Okay, so in order to do this, we're going to use a new button that we haven't used this year. It's right here in the middle, underneath the zoom, which is stat. So we're going to hit second stat, and that's going to give us a list, second stat. Oh, just hit stat, there we go. And then we're going to go to edit. So we're going to put our list in there. We're going to use the stat key. Oops, just stat. And then we're going to click edit, option number 1. Okay, so in option number 1, this gives me all of those lists. So we're going to make our list 1 our years after 1994. So we've got 0, 4, 8, 14, 21, 24, and 26, enter. So we've got all of those values there. And now we're going to put in the billions of net worth at those years. So 0, 12, 10, 250, 100. Whoops. I gotta fix it. It told me I did something wrong. And then I'm also missing something, so let's try again. Oops. This one is supposed to be, my list 1 is off. That's a problem. So let's try 0 again. I have to make sure that my data is right. 4, 8, 14, 21, 24, 26. Okay, there we go. And now our list 3, oops, let's put it back. Where's my list 3? Or my list 2, I should say. Here's my list 2. And then we have 0, 12, 10, 250, 100, and now we have that 136 ready to go. Okay, so your lists should look like mine, list 1 and list 2. Once we have that, we're going to go ahead and graph it so that we can actually see what this data is. In order to do that, because we're using a list, we're going to use stat plot. So you're going to go second y equals. So to graph this, you're going to go second and hit your y equals key, which triggers the stat plot. Okay, so we're going to see this top one. It says list 1, list 2. We're going to hit enter so it turns it on. Okay, and now we're going to hit graph, and we can see here that we can see our graph. Now we want to be able to see our window, so go ahead and hit window, and we're going to change it so that it will fit all of our data. So our X values, our list 1, are going to go from 0 to 26. Okay, so let's make that max 30. We'll go on a scale of 1, that's fine. Our y values are going to go from 0 to 136. Let's round that up to 150. But instead of going a scale of 1 at a time, let's do a scale of maybe 10 at a time. Let's go ahead and graph this now, and we can actually see our data. Push pause if you need to work on that and make sure that your your calculator looks the same. Okay, so now we're actually going to get to the part where we're going to tell our calculator what to do. Okay, so now that we've got our graph here, we're going to tell our calculator, and we're going to click second, the calc key. Okay, so you're going to get second calc. Oops, second calc. And we're going to calculate, oops. Hold on. Let me find it before I tell you what to do. Oh, there it goes. Okay. You're actually going to go second. Let's fix this. You're going to hit second, and then you're going to hit stat. Okay, so second stat. And then you're going to go to the calc option. Go to the calc option. And under the calc option, do you see how it says, here's linear regression, here's quadratic regression, here's cubic regression? Because we have a cubic model, we're going to use regression of the cubic. So you're going to choose the regression model that works for us. That's option 6 right now is cubic. And do you see how it's X list is our list 1? That's where we put our list 1 data. If you put it in a different list, you would change it now. Our Y list is L2, which is where we put our list 2. Good job. And then here's what I want you to do. To store your regression, because we're going to save this, and we're going to click vars to put it in Y1, go to Y vars, hit function 1, and we're going to store it in Y1, enter. Now we're going to calculate this, okay? So here's what it does for us. And I'm going to write it down right here. So it says, hey, your cubic regression is going to be Y equals A, which in this case is 0.0278. So we're going to go ax cubed, which is 0.028x cubed, plus b, which in this case is negative 0.6996, which is 700 if I round it, and that's x squared, plus c, we know c is 4.7078, so that's going to be 708x plus the value of d, which is 1.092. Okay, so there's my equation. And now, because remember when we stored it, go back and look at our y equals. So I've got it all stored in here. If we look through, it stored the whole thing for us. This is beautiful. So what I'm going to do now is I'm actually going to click graph, and you'll see that it takes my stat plot that I just used to look at my list, and it graphs my regression equation, which pretty well fits my numbers. Now, it's not exact. We have some above and below, but it is an approximation. So that's what we see. And it says use our model to find the average rate of change from 2008 to 2022. So to find the average rate of change, we're looking for F of 2022, which would be how many years after? Let's see, 22 minus 1994 would be 28 years after, and 2008 after 1994 would give us what? 14 years after. So we're going to look at F of 28 minus F of 14 all over 28 minus 14. So we know here, let's look for F of 28. So we're going to go back to the table. So second table, here's my function, and I'm going to look up, hey, what's my value when X is 28? Okay, so I get F of 28 is 194.97. Okay, and we're going to subtract F of 14. So if I look at those values for X, when X is 14, Y is 6.1934. Okay, and then we know 28 minus 14 is 14. So now I'm going to move back to just our numbers here. And we've got this, if I subtract it out, we get about 188.775 all over 14, which is approximately $13.484 billion per year is the average rate of change from those years. Wow. Man, I wish my average rate of change looked like that. Okay, so let's talk about types of regression. If you have information that looks kind of like this, it's approximately linear. If we see kind of information that kind of looks like this would be a quadratic, okay? And sometimes you'll only see like a little bit, it doesn't mean that it's not quadratic because it can still look like this. Something that looks cubic means we have 3 different directions. Something that's quartic could look like this, 4 different directions. Something that's exponential is going to go really steep as we increase, like this. Something that's logarithmic is going to go flat as we increase. Something that's logistic is going to look like this. And then the sine wave goes back and forth around the x-axis. All right, let's go to the next page. So let's talk about something that's inversely proportional now. So I want you to remember inverse means that as x increases, y decreases, right? Or the vice versa. So that's what inversely means. The force in newtons exerted by a magnet on a metal object is inversely proportional. So the more force, the less the distance. The more the distance, the less the force is what we're talking about here. If a magnet exerts 60 newtons on a metal object 2 centimeters away, what will the force be in 10 newtons? So let's talk about this, okay? So inversely means as x increases, y decreases. So that means we're going to put x in our denominator. And in the numerator, we'll have k, which is just the constant of proportionality. So basically how proportional it is. Okay, so first, in order to solve for k, we're going to set this up. So when we're talking about y, we're actually talking about here, the specific, what we're looking at is force. So we're going to say force equals the constant of proportionality divided by, what's it inversely related to? It's inversely related to its distance in centimeters. So we're going to say centimeter, and then it's also squared. So we're going to put distance squared. So let's find k. So in order to find k, we're going to plug in a specific value for the force. So this is our first one. So if it's 60 newtons of force, we're going to put 60 here instead of F equals, we don't know what k is, all over the distance here is 2 centimeters away. So we're going to put 2 for the distance and we're going to square it. Let's go ahead and find the k. So this becomes 60 equals k over 4. To solve for k, we're going to multiply both sides by 4, and we get 240 equals k. So we're going to use this to write the equation, okay? So we know F equals k, our constant of proportionality, which we found out is exactly 240, divided by the d squared. So this is our actual force equation for this specific case. Okay, so now the second part of the equation says, hey, what will the distance be when the force is 10 newtons? So what are we looking for? What's the distance going to be? So I don't know. The distance is going to be something, but I do know the constant of proportionality is 240, and then the force they're telling me is 10. So let's solve for d. In order to get d out of the denominator, we're going to multiply it on both sides, and we get d squared times 10 equals 240. Divide both sides by 200, or by 10 rather, and we get d squared equals 24. Take the square root of both sides, so we know d, and distance can't be negative, so it's not going to be plus or minus, it's just going to be positive, is the square root of 24. And that's in centimeters. Okay. Last one, let's study some piecewise functions. So remember, piecewise functions gives you different cases. So we have 3 cases here. So if we're talking about a snowstorm where x is the time in hours and the function is the depth of snow. So the first 4 hours of the snowstorm, this is how much snow we've gotten. Between hours 4 and 6, this is how much snow there is. And between hours 6 and 9 after the snowstorm starts, this is how much snow we have. So let's see what we can do. So if we're looking for f of 7, that means we're going to have to decide which function we're looking for. So this is what we look for first. Which case works for when x is 7? So here, this is, hey, when x is between 0 and 4, that's not 7. If 4 to 6, that's not 7. And then also, this is when 6 to 9. So f of 7 would be included in this function here. So we're going to look here. This tells me when x plus 3 is our function and 7 replaces the x. So we get 10. So here's what it means in this context. So we know that the depth of snow is 10 inches 7 hours after or into the snowstorm. Okay, now it says find the average rate of change from 4 to 5 hours. Well, we know how to do this. We're going to find the f of 5 minus f of 4 all over 5 minus 4. So let's find f of 5 first. So remember, we're going to have to look, here's f of 5. It's going to be in here between 4 and 6. Therefore, f of 5 is actually 12. And we're going to subtract, well, what is f of 4? Well, where do we look for f of 4? 4 is going to be in here. We're going to plug it into, I'm going to do this right here, f of 4 equals 1/4 4 squared plus 2 times 4. Well, I know this is going to be 1/4 of 16 is 4, plus 2 times 4 is 8. This is 12. So we put the 12 here for f of 4. 5 minus 4 is 1. So 12 minus 12 is 0 over 1. What does this mean? Hey, the average rate of change, the AROC from 4 to 5 hours is 0 feet of snow per hour. So that just means, hey, between the 4th and 5th hour, it didn't snow. The change, it didn't melt. It also didn't snow more. So we have the same amount of snow. All right, that's it. We'll see you next class.